When we investigate space, we gaze straight toward our own beginning. We are offspring of the stars. Brian Cox realizes that before the Big Bang, there was something horrendous. It is hard for common people to imagine the monstrosity of the condition that resulted in all that we know today: stars, the Milky Way, millions of other galaxies, and, ultimately, ourselves. The famous astrophysicist tries to explain this incredible state of the universe before its birth in a straightforward way, and his answer can even explain who we are, where we come from, and who we are as stars. What were they made for? These inquiries have been driving people since they have been able to think. We are standing here on our tiny globe, which, compared to the newly known size of the universe, is not even a speck of dust. And we are trying to understand what it all means. We look billions of light years into space with telescopes, and instead of answers, more and more questions arise. It almost seems like the universe is trying to escape our research, or as though it is constantly answering our questions, and we are just not able to see these answers. Brian Cox shares the view that our universe in its entirety is still a great mystery. But the English scientist is also sure that the universe is definitely explorable, and that it's not all that difficult to uncover the secrets of this seemingly limitless space if we look closely. Was there really light in the beginning? A statement from Brian Cox: light is the main connection to the universe. Have you ever wondered if the Bible and science share anything in common? Both try to explain how the world was created, what rules apply in it, and who we ourselves are. The Bible states that in the beginning, there was God, and He made the world from nothing in 7 days. In the world of the Christian God, light quickly appeared. However, science questions this. If we trust the currently accepted standard model of cosmology, there was no light at all in the universe for many millennia. For this reason alone, scientists long believed that we humans could never be able to see the beginning of the universe. The justification for this is simple: we can only see light. Our telescopes filter light traces that have been traveling for billions of years and collect them into images. Where there was and is no light, our telescopes can't see anything either, and we can't investigate it. If the Big Bang happened in the dark, and it was dark for ages afterward, we would never be able to see these epochs. But now, the James Webb Space Telescope has shown us something different. This wonder of technology looks back an astonishing 13.6 billion light-years in time for us, moving very close to the boundary of the Big Bang, which is thought to have occurred around 13.8 billion years ago. Now comes the first surprise: Webb shouldn't actually be able to see anything from 13.6 billion years ago. This epoch was supposedly the Dark Age. There was no light, and thus, nothing for us to observe. However, Webb's images show us columns and lines of bright and beautiful galaxies. So, there was indeed matter, and it was already incredibly well developed at that time. So far, there is no hint of a Dark Age, and we have to ask whether our science is really correct when it claims that the universe came from nothing and was dark for a long time. Was light and matter there sooner than we thought? And is the Bible somehow right when it claims that light was present quickly or even from the start? To understand this, we first need to see what light actually is. Before the Big Bang, there was light. A statement from Richard Feynman: if quantum mechanics has not shocked you to the core, you have not understood it. The great mathematician Albert Einstein was the first to describe the nature of light. He believed that light consists of individual photons, each of which collides with electrons, exciting them and thus generating visible light through electromagnetic waves. Light is therefore created as a kind of force through spin, friction, or collisions. Now, we must realize that these processes occur at all known subatomic levels. Quanta and even smaller particles fluctuate, which means they appear and disappear again. They interact slightly with each other, or they are connected to dimensions we have not yet understood or explored. All these processes are movements and dynamics that generate waves and radiation. If spins, frictions, and collisions are also generated here, a kind of radiation, and therefore a form of light, will also arise. Only these light waves move outside our normal ability to see them. Richard Feynman was one of the first quantum physicists to understand the true extent of this science. Quanta are the basis of all matter, not the Big Bang or grand material phenomena like stars or planets. Everything is made of tiny particles that fluctuate and shine. These particles are uncanny, or even shocking, because they behave completely irrationally. Quanta only form fixed states when they are observed, otherwise, they remain in a state we could describe as unformed potential until they commit. They can be either, and the truly frightening thing is that they theoretically hold this status even while they form a solid structure. A quantum that becomes the building block for a table forms this solid structure as long as we observe it, but it also holds the potential to be a chair, a tiger, or a drop of water. What does this tell us about the origin of our universe and what came before it? This question is simple to answer. Our universe is possibly one potential reality, formed into its now visible shape and structure. But at the same time, it is also countless other things, or at least contains the potential for many things. Brian Cox, before the universe, there could not have been nothing. A statement from Brian Cox: the goal of particle physics is to explain what everything is made of and how it is connected, me, you, the Earth, the Sun, and 100 billion more suns. The magic of our science is that it's not as simple as we sometimes think. If we remember physics class or other branches of science, many of us have good or even bad memories of numbers, data, and facts. But real science, and even physics, is far more adventurous than memorizing formulas and numbers. Fundamentally, scientists don't really know that much about the true secrets of the universe. As Brian Cox says, our only connection to the universe is light, but there is more to the universe than light, and we don't even begin to see it. Particle physics has its own ways to uncover the mystery of the universe and, additionally, of our reality. The basics are simple. You take a particle and then split it into its component parts until it can't be split any further. The theory sounds good, but the practice is tricky, because so far, all known particles can be split into even smaller particles. Imagine a particle is a city, then a quantum might be an orange that lies somewhere on a table in this city, and we know even smaller particles, which would then be just a few crumbs inside this city or the dust that has accumulated somewhere on a table. We can't even truly see atoms, and even our best scientists can't see the other particles, we just know that they are there because we can observe their effects. No matter how far and deep experts have explored these dimensions, they have not found the basis of creation. It's still unclear today what matter really consists of and how it is formed. Matter is said to have originated at the beginning of the Big Bang. At first, there were only free particles, and everything was too hot and swirling to allow for solid connections between the particles. Then it cooled down, and the first chains of particles eventually formed atoms, and finally matter, or so the theory says. Before the Big Bang, there must have been Einstein's nothing, essentially. That's what the theory of relativity implies. However, physicists have now found that nothing cannot theoretically exist. But how did they reach this conclusion? In quantum physics, it was shown that a particle can never be completely destroyed or eliminated. The information that formed the particle always remains present. Therefore, nothing could not have existed before the Big Bang. Essentially, the information that later formed the universe must have been present. Now, of course, we can ask further questions, such as, where did this information come from? Quantum scientists explain this with a quantum fluctuation, which, in plain language, means that a limitless sea of particles existed. The particles emerged, annihilated each other, and then vanished again, because no force or thing that we know or can name appeared within this neutral sea. Variance, this nothingness didn't consume any space either, and no time passed. By the by, the nothingness was everything and significantly more. Inside the variance, not just the potential for our universe as it is existed, but also for countless other universes or things, spaces and dimensions that we can't imagine. The prospect that there were countless other variations of what we now know as the universe is mind-boggling. Imagine a universe in which everything is pink, in which matter flows instead of being solid, in which only thoughts exist, or time runs in reverse. These are just 4 variations of sextillion or countless more. But for what reason did our universe appear? And for what reason did we, humans who don't fully understand how the universe works, come into being? These questions can push us to the brink of our minds, and perhaps we need to go beyond these limits to comprehend the true nature and variety of our universe. Subscribe now and don't miss any new videos.